That's what we're going to do, and just know that this is actually a pretty useful thing. Like, I used to think long division on polynomials was one of those things that wasn't useful, but I've used it before in my own research and things, and you use it to help you factor. It's a factoring tool. And so anyway, let's get started. I usually start by sort of reminding ourselves how to do regular long division, because polynomial long division is the same thing. You know, eventually we want to talk about how to do a problem like this. Before we do a problem like that, let's just remember how to do kind of an easy problem, because the steps are very, very similar, and the concepts and the reasoning is very similar. So let's remind ourselves how to do like regular long division. So if we want to divide 227 by 3, you set it up like this, right? You do the 227 underneath the division sign there, and the 3 on the outside, right? And then the way you think about these problems are you think about the number on the outside going into the number on the inside. So how many times does 3 go into 2? Well, 2 is less than 3, so we add the second number, right? And you say, how many times does 3 go into 22? You say, well, that happens 7 times, and so you put a 7 on top, right? And then you remember what you do at that point is you take that 7 and you multiply it by the 3 out front, and you write that underneath. Remember that? And so you write like a 21 there, because that's 7 times 3. And then at that point, you subtract. You subtract the two numbers that are in that spot. And 22 minus 21 is 1. And you bring down the 7. Remember this? Again, I just want to review this because the next thing is going to look the exact same, and the reasoning is very, very similar. And so I just want to make sure that this process is clear before we do that. Okay, and then you say, okay, 3 goes into 17 how many times? That goes in 5 times, and so you put a 5 up top. And then you multiply that 5 back through the 3. And so 5 times 3 was 15. And then we do that subtraction. 17 minus 15 is 2. And this is where we know when to stop, right? We stop when the number down here is less than the number up there. And so this would be our remainder then. And we can write our answer in 2 ways. We can either say that 227 divided by 3 equals 75 and 2/3. Did I mess up? We have a question.
Maybe I'm wrong, but the way that I remember writing it is that you take the 2 and then you add the decimal point and then you add the 0 and then you see how many times it goes in. And then once it starts repeating, you just...
What do you mean you add a decimal point?
So 75 point, and then you put a 0 down next to the 2, so it's 20. And how many times 3 goes into 20?
Oh, that's interesting.
And then you put that number, and then you do the same thing. And like with this case, it's 0.6666, so just keep going.
But if you put a 0 after it, you're not going to get 66, you get 0. Or you put a 0 after this one.
And then you see how many times 3 goes into it, and then...
So that's a way that we could, what you're describing is a way that we could get a decimal answer out of this. And as I've said before, decimals are not as good as fractions. Fractions are better because 0.6666 gives you, let me add another 6, 0.6666 gives you 4 6s, but 2/3 gives you infinitely many 6s. So anyway, you're right, but and that also doesn't apply to the next thing anyway. Anyway, that's a little aside. Anyway, so we can write this as 227 divided by 3 equals 75 and 2/3, or we could say 227 is what you get when you multiply 75 times 3 and then add 2. And so those are equivalent ways to write the same kind of the same result there. And I'm writing it in those 2 ways because I'm going to write polynomial division answers in 2 ways as well. And so I just wanted you to be familiar with those 2 forms right off the bat. Questions about that process? Remember that? So this is one way we could write this, divide 227 by 3. We could also write a division problem like this, right? 107 divided by 5. You could also write it like this, just to be clear. 107 divided by 5 is also that fraction. And so that's another way to think about it. Just kind of getting you familiar with some of those notations, right? That's an alternative way to write that. And anyway, you can do this one similarly, right? You write the 5 out front, the 107 inside the division sign, and then we say 5 goes into 10 2 times, You multiply the 2 times the 5 to get that 10 and subtract. And then you bring down the 7. And then we say 5 goes into 7 one time. Multiply the 5 and the 1 to get 5. Do the subtraction to get 2. And again, that's our remainder. And so, again, we could write this as 107 divided by 5 is 21 2/5. Or the other way to say that is 107 equals 21 times 5 plus 2. And so we want to do the same process with functions. That's what's on the next page. But we're going to do the same exact thing. And I wanted you to just be familiar with the, the sort of the simple version here. Now what I wrote down on the rest of the page are instructions. And I don't recommend we read through them in detail. I recommend that this page, you use it as a reference later on if you forget what we did or how to do these problems, right? If you look at your homework and you're starting to do that and you're like, what did we do here? Then you can go back and look at this and this will help you. I do want to point out 2 things, or maybe more than 2 things about it, which is that, first, the vocab. So the polynomial doing the dividing, we call that the divisor. So in this problem up here, the divisor is 5, for example, in this one. And the thing that's being divided we call the dividend. And so up here, this would be 107 would be the dividend. Kind of an important thing here is what I underlined at the end of step 1. I'll put a couple stars next to it, and I'll point this out later, which is that if you're missing a variable, you need to write that in as a 0. So for example, if you have an x cubed and then the next variable is x, you're missing x squared, and you would want to write in 0x squared. Again, I'll point that out in an example on the next page, but just wanted to sort of highlight that so you highlight it on your own page. And then you do the division very similar to what we just did, except you just focus on the first term of the divisor. So you ignore everything except the first term, and the first term only comes in when you multiply things back through. Again, you'll see that on the next page. But then 3, 4, and 5 are very similar to what we did above. You multiply your answer back through your divisor. You subtract your answer just like we did before. And then you stop once you reach a remainder. And what I said here was, you know you reach a remainder when you can't perform any more operations. In other words, you stop when the degree of your divisor is more than the degree of your answer. What does degree mean again? So there's going to be more than one power. You're right, it's something to do with the power, but it's the what power? The largest power, yeah. So the degree means the largest exponent, right? And you'll see what I mean by that, but again, these notes may just help you later if you're confused about stuff afterwards. Let's do an example. I'm going to go back through these steps as we look at this example. Just want you to be kind of aware of them as we go. Questions at all before we do that? Okay. So let's look at the first example here. So we want to do this division problem up top. And we write it down just like we wrote down the last one. Very similar format. Excuse me. So we write down x minus 2, which is our divisor, outside the division sign. Try not to write too big here. We're going to fill up this whole space pretty quick. And then you write the other one inside. So we've got our divisor outside, our dividend inside. And then we start doing the dividing. But, like step 1 says on the previous page, step 2, we only think about the first term doing the dividing. So what I mean by that is we focus in on the x. And I'm going to write that down here. We just think about this term. you read that right there? Yeah. Just think about dividing the first term into the polynomial. And in this case, it's x. If you look down at the one below it, right, we're gonna, on this one, just kind of looking ahead, we're just gonna focus on the x squared in this one and not the x plus 3. Right, so you just focus on the first term of the divisor. And what we do is we think, how many times does x go into x cubed? Or the other way to say that is, what do I need to multiply x by in order to get x cubed? Right, that's the other way to say that. Yeah, so x squared is that answer, right? So the answer, and then we put that right up here. Because x squared times x gives me x cubed. Just very similar to what we did in the last page. And I'm going to write the details down again, mostly for later and for people who weren't here. But I'm going to write a number 1 here, and then over on the right, I'm going to note how I got number 1. So I got number 1 on this page by thinking, what times x gives me x cubed? And my answer was x squared, and so that's why I put an x squared on the top. Is that right? And then it's very similar. We do like the same thing. We take that x cubed, the x squared, and we multiply it back through the x minus 2. And so when I multiply that back through, I get x squared minus 2x squared. X cubed, thank you. It better be x cubed, right? Because we want to cancel those out. Yeah. So let me just note that. So this step, what I got number 2 from is thinking, or multiplying the x squared times x minus 2. And then we do the subtraction. We do subtraction just like we did in the last page. And notice how I'm putting, this is like the one way that people mess these up. Not the one way, but certainly by far the most common way people mess these up is you forget to put parentheses around this. And I even like to write the minus sign in there so that I remember that this minus sign that I'm pointing to, is going to make the other minus sign a plus. It's very important. This is the one way people mess these up. So we do like x cubed minus x cubed is a 0x cubed. But then x squared minus x squared, minus x squared minus a minus 2x squared makes it a plus. And we end up with a plus x squared. Super important. Just write parentheses around it and a minus sign, and it'll help you remember to do that. I can't stress that enough. Because as soon as you mess that up, if you subtracted instead of added there, everything else after is wrong. And so like these are not super complicated problems. They just require you to be careful. This too? Yeah. I subtracted these. So I did the x squared minus x squared plus 2 gave me a positive 1. Other questions? And then just like on the last page, we bring down the next thing. So we bring down this minus 2x next. And then we do the exact same thing again. We just focus on the x, and we say, what do I have to multiply x by in order to get x squared? So that's x, right? X times x is x squared. So I put a plus x in. And again, I will just kind of note here how I got that. I got 3 because I thought about what times x would give me x squared. And the answer is x times x. And then you multiply back through. So x multiplies into the x minus 2. And we get x squared minus 2x. Right, so that's where that one came from. Let's note that. So number 4 says, number 4 came from taking the x and multiplying it through x minus 2. And then I put my things in my answer here in parentheses to remind me that this negative sign is going to make this a plus again. And so we get 0x squared plus 0x, and then we bring down the 6. And this is where we want to stop. This is the remainder, and I know it's the remainder because based on the last page, I wrote you stop basically when you can't do anything else is the short of it, but that means that the degree of the divisor is less than the degree of what we're trying to divide into, right? And so this thing here has degree 0, and the divisor has degree 1. And so I'm stopping here because 0 is less than 1. I mean, the other way to think about it is if we tried to do something else, I would say x times what gives me 6. I would have to divide by x in that case, and that doesn't really make sense. And so that doesn't make sense to think about that. And so that's another indication that this is the remainder. So stop here. Because 6 has degree 0. Does that make sense that it has degree 0? And x minus 2 has degree 1. And so 0 is less than 1. And so this is telling us we need to stop. And so that means 6 is the remainder. I'm going to write, this is not kind of the answer yet. This is the work that gives us the answer. This is all good work. I want to write my final answer kind of over here on the left. But let me see if there's any questions first. Does it make sense this has a degree 0? Right? There's 0 x's there is one way to think about that. The other way to think about it is there's like an x raised to the 0 power right there. Because that's just equal to 1, right? So this has degree 0. Is it okay? So this box down here is helping us figure out how to write the answer down. So this says when we have a polynomial, two polynomials, d of x and p of x, then there are unique polynomials q and r. Q stands for quotient, r stands for remainder, right? D stands for dividend, such that divisor. Our original dividend equals the divisor times the quotient plus the remainder. This is the exact form that we wrote things down on the last page. Right, when we wrote these down, this was like P equals D times Q plus R. This is the exact form that we wrote those things down on before. And so we're doing the same thing again. And so I'm going to write that down in that exact same form. And again, this is kind of the point. The point of this is that we're able to factor it. And look, we're going to be able to factor it. What we just found out is that our original function, x cubed, you can see that, right? X cubed minus x squared minus 2x plus 6 is equal to our divisor, our answer, my goodness, our quotient times our divisor plus our remainder. Right, so this is in that form. This is my p of x. This is my d of x. I wrote them in the wrong order, but that's okay. This is my q of x. And this is my r of x. And so again, this is useful for factoring, right? If we want to factor this, and I knew one of the factors, you can do some long division, and it helps you factor it. This is the one time I've ever used this in practice, is to factor. The other version of what we wrote on the other page is dividing all this stuff by x minus 2. If I divided everything in this function by x minus 2, there'd be an x minus 2 here. It would cancel this x minus 2 in this piece, and the 6 would be divided by x minus 2. And so that's the other form of the answer. So the other way we could write this is that our dividend divided by our divisor equals our quotient plus our remainder. 6x minus 2's. And so those are both really good ways to write the answer. You'll see in the homework's going to want you to enter them in individually. It'll say, oh, p of x equals q of x times d of x plus r of x, where q equals, and you'll enter q in, and where d equals, and you'll enter d in, where r equals, and you'll enter r in. So it wants it kind of in this form, but I just want to show you this one as well. Any questions about this? Yeah.
So I understand how to do this, but I don't understand why we ignore the minus 2.
We ignore the minus 2. We ignore it just when we're dividing. But the minus 2 comes into play when we multiply things back through, right?
Okay.
And so we ignore it in some sense because x has the biggest power, and so we want to make sure the biggest power can go into those things. And then the 2 comes into play when we multiply things back too. That's how we end up accounting for it. So this term came from the 2, and this term came from the 2.
Okay.
And so the 2 gets used, it's just not part of the dividing process. You can also check too. I just want to note here, we can always check this stuff, because if you multiply this right-hand side out, it better equal the left-hand side. So you can always check your answer if you want, right? Like you can do this multiplication, and then you would see that it equals x cubed minus 2x squared plus x squared minus 2x plus 6. And if you simplify that, you get back to your original problem. You get back to x cubed minus x squared minus 2x plus 6. And so you can always just kind of double check to see if it's true if you're getting stuck somewhere. When you guys learn a different way to do this? Some people like to learn a way called, shoot, I just had it in my head, now I forgot it. Someone help me? Yeah, what was it?
Synthetic.
Yeah, the synthetic division. If you know how to do synthetic division, you're welcome to do it on some of these problems. I'm not going to teach it. You're welcome to do it. The thing with synthetic division is that it only works with problems that have a degree 1 in the divisor. And so if, like the next problem, on the next problem, the divisor has an x squared in it, and so synthetic division is not going to work on this one. And so if you want to use synthetic division, you're welcome to do it on these type of problems, but just know that it's not going to work on these types of problems with not a 1 in there. Any questions before we look at the next one? And we'll wrap it up with a short quiz. Okay, cool. So this one's a little bit more complicated, again, because we've got more terms in there, higher powers, that kind of stuff. It's the same process, and it's not any harder, it's just a little bit longer. So we set it up the same way. We get our divisor, put it in the outside here, and we put our dividend underneath the square root. I mean, it looks like a square root, it's not a square root though. And in this one, we're only thinking about the x squared when we're doing the dividing. We don't use the x or the 3. The x or the 3 come in when we multiply whatever's up here back through. So we just focus in on the x squared. And we think x squared times what gives me 3x to the 4th? Well, I need a 3 at least, right? Because that's going to give me the 3. And then I need 2 more powers, 2 more exponents, and so I'm going to multiply by x squared. So 3x squared goes in that spot. I've actually messed something up, but I'm going to keep going as a teaching point. Hopefully maybe you can catch me, or maybe someone call me. Don't say it yet, though. At this point, we need to multiply this back through here, right? And so we get 3x to the 4th. Oh, yeah. Plus 3x squared. Plus 9x. I'm sorry, that would be cubed. 3x cubed. Plus 9x squared. Let me just change that. That's a cubed, not a squared. And now we want to do the subtraction. But what am I missing? We're missing the x squared. Right, so what I had wrote was on that first page, the thing I highlighted with a star and then forgot to add it myself, if you're missing a variable, remember to write any missing variable exponents as a 0. And so in this problem, we were missing an x squared. Right? We have an x to the fourth, an x cubed, and then it goes to x. And so when I'm trying to do the subtraction, I can do 3x to the fourth minus 3x to the fourth. I can do minus 5x cubed minus 3x cubed. But minus 20x minus 9x squared doesn't make sense. Right? Those are not like terms. You can't subtract those two things. And if you weren't careful and you didn't notice that when you did it, you might skip over that and do something wrong. So instead of this, we need to put in a 0x squared. So I'm going to add in, I'm going to do plus 0x squared, and then go on with the rest of it. Does that make sense? Do you see how that doesn't work if you don't do that? Because you wouldn't have this, you don't have this like term to subtract from in that case. So that's like a second kind of real common way that people often mess these ones up, is you forget to enter that in. Does everyone see that? Is that okay? I actually didn't mean to mess that up, but maybe that was a good teaching point. You can tell me, I don't know. Anyway, I put this in parentheses again, right? It's a nice long one, so I want to make sure I'm subtracting everything. So I do 3x to the fourth minus 3x to the fourth. That obviously gives me a 0. A minus 5 minus 3 gives me a minus 8. And then a 0 minus 9 will give me a minus 9. And then we bring down the minus 20. And then you just go on to the next one, right? You do the same thing again. X squared times what gives me minus 8x cubed. I need a minus 8, obviously. And then it's an increase of 1 power, and so it's going to be an x to the 1. So minus 8x. And then you multiply this back through. Right? You multiply the minus 8x times x squared plus x plus 3. And we get minus 8x cubed minus 8x squared minus 24x. It's particularly important. Got to be real careful. I know I've said this a number of times, but I know someone's still going to make this mistake. Put them in parentheses. This negative sign is making all of these addition. It's going to make it all addition. Be real careful. And so we'll end up with a 0x cubed, a minus 9 plus 8 gives me a minus 1x squared. And then minus 20 plus 24 is a plus 4x. Bring down the negative 5. And then on the last step here, we say x squared times what gives me minus x squared. That's got to be a minus 1, right? And so we put a minus 1 there, we multiply it through, and we do our final step of subtraction. Again, all these are going to end up being plus, so be careful. And so, so this one's obviously 0. 4 plus 1 is 5x. And then a minus 5 plus 3 is minus 2. And we know to stop, right? We know to stop because we look down here, and this has degree 1. 5x minus 2 has degree 1, and our divisor has degree 2. And so it's less than that, right? 1's less than 2, and so we stop. Right, I'm going to write that down. So we stop here. This is the remainder since 5x minus 2 has degree 1, and x squared plus x plus 3 has degree 2. 2 is less than 1, so stop dividing. Questions about that before we write down the answer? Oops, sorry. Sorry, I went off the screen there. Again, it's not, it's like real simple multiplication, simple distribution, simple addition and subtraction. You just have to be careful about the minuses, careful about adding those zeros in here, right? Don't forget about this. This is adding this 0 in there was a really important part of this one. That's why I did this one like this. And so then our answer can be written as follows. We can write it in two ways. We can write it as 3x to the 4th minus 5x cubed minus 20x minus 5 is equal to our dividend, or our divisor, man, I can't get those words straight, times our quotient plus our remainder. That's one way to write it. That's what it says up in the box there, right? This is my p of x, d of x, q of x, and r of x. Or we can write it as a fraction in the other way. Right? So if we divide everything in this function by x squared plus x plus 3, we would get this.
I think it's -1 plus 1.
Ah, thank you. Yeah, there should be a -1 there if you wrote that down already. And it brings us to this next theorem here, which says that some number is a 0 of our polynomial if and only if x minus that number is a factor of the polynomial. So for example, we've seen this before, it's just kind of writing it out as a theorem. We know that we can factor x squared minus 3x plus 2, and we can factor that into x minus 2, x minus 1. In other words, 1 and 2 are both zeros of the polynomial. And so what this is saying is, if we know that that's a 0, if c is a 0, then x minus c must be a factor. And this is literally what that's showing, right? So 2 is a 0 and 1 is a 0, and so x minus 2 and x minus 1 are the two factors. In other words, the other way to say that is imagine we divided both sides of this equation by either one of those, by x minus 1, say. Then that would be saying like this. That should be squared. If we divide x squared minus 3x plus 2, that's our original polynomial. If we divide that by x minus 1, we just get x minus 2 out. And specifically, no remainder. X minus 2 plus no remainder. And so that's what this theorem says. This theorem says if we know something's a factor of the polynomial, then when we divide it, that polynomial by that factor, we don't get a remainder out. And that's exactly what I wrote here. This means that if c is a factor, then x minus c should evenly divide the polynomial with no remainder. Okay, so there should be no remainder when you do that. And so I'm going to ask you to do this one and start us off here, now that we've practiced these on the last page, right? We want to use the factors theorem to show that x minus 2 is a factor of this cubic, x cubed plus 2x squared minus 3x minus 10. And so what, in other words, i.e., what this is saying is divide the polynomial, p of x, by the factor, x minus 2, and see that there's no remainder. So let's set this one up just like we've set all the other ones up, right? We start by writing out our division sign. We put our polynomial inside, x cubed plus 2x squared minus 3x minus 10. I'm not missing any variables. I've got a cube, a squared, a single, and a 0, right? So I don't have to add any, so that's good. And then I put my x minus 2, my divisor, on the outside. And remember, I'll do one step, and then I'm going to ask you to finish it. Remember, when we're doing these, and if you weren't here last time, then maybe this is the first time you're hearing this, but when we're doing these, you think about just the first term dividing into the polynomial. That's why I boxed the x, right? So when I look at x cubed, I think, what do I need to multiply x by that will give me x cubed, right? And so that is x squared. And so that's why my first thing I write down is x squared. Because when I multiply x squared and x, I get x cubed. And then you multiply the x squared back through the x minus 2, and we get x cubed minus 2x squared. And this is one of those times you got to be real careful. Remember, we make our division, or our subtraction sign, and I'm being careful because this subtraction sign is going to make this a plus, right? So the x cubes cancel out into 0, but then we have 2x squared minus a minus 2x squared. So in other words, it's a plus 4x squared. Real careful about that. Can't stress that enough. And then we bring down the minus 3x, and we do it all over again. All right, and then we focus in on the 4x squared. So go ahead and finish this one. All right, so you want to think about, what do I need to multiply x by to give me 4x squared, and then that goes up top here. And just know that down in the bottom here, dot, 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 once you get down here, you should end up with 0 remainder. That's the point of this problem, is because x minus 2 is a factor, and so we should end up with no remainder. So that should be a good indication that you did this one right. All right, go ahead and finish this one off if you can. If you need some help with this, let me know, especially if you maybe missed last time and you had a hard time understanding the notes or anything like that. If you need some help on this one, let me know. But take take a few minutes and see if you can finish this one. Again, we should end up with no remainder.
I mean, I guess you could mess it up enough so that you end up canceling the remainder out, but not getting the remainder on this problem is real. So that
I mean, like if you do everything right, it doesn't matter what it is. It's up to
no, that's what I mean. I guess the goal is zero remainder equals zero. The fact that you have zero remainder is a really good sign that this is right. Because these multipliers are going to give you all this stuff. So like in theory, you could mess this up bad enough so that
right, so it looks like folks are ready to see this one. So at this point, I'm thinking x times what gives me the 4x squared, so I need a plus 4, and then an additional x. And then I take that 4x and I multiply it back through, right? That's where this minus 2 comes into play. The only time you use the minus 2 is when you take the numbers up here and you multiply through here. So the 4 times x gives me the 4x squared, and then 4x times minus 2 is minus 8x. And then you want to be careful here, right? You do the subtraction, and so you're going to end up with a 0x squared, but then you get minus 3 plus 8. Gives me a plus 5. And then we bring down the minus 10. Is that okay so far? And then this will be the last step. I think x times what gives me 5x. That's just plus 5. And then when you multiply that 5 back through the x minus 2, you get the exact same thing that's already down here, which means they're going to cancel. Right, when you do that subtraction, you get 5 minus 5 and minus 10 plus 10. And so you just get 0 plus 0, i.e. no remainder. And that was the goal here. That's showing us that x minus 2 is a factor of this thing, because we ended up with no remainder. Questions about that before I write down the final answer? Right, because this is like the work. This is good work, and this is, most of the problem. But the answer, the real answer, is that our polynomial x cubed plus 2x minus 3x plus 10, I'm sorry, one of those should be squared, 2x squared, that is equal to x minus 2, which is our divisor, times our dividend, x squared plus 4x plus 5. Whoops, yeah, I forgot to copy that down wrong. Thanks. Should be a minus down here. I'll remind you, this is the one time I've used this in practice in my own research and stuff, is when I know something's a factor. If you know x minus 2 is a factor, then it lets you divide this thing using long division, and then you can get it in factored form. And now I can find the zeros of this thing if I wanted to, right? It's easy because I could use the quadratic formula on this piece, and I could just set this piece equal to 0. And so this is it's a nice, useful method at times. All right, questions? Okay, great. Let's go to the next page then. Oh no, it's the same page. Sorry, bottom of this page. The other kind of way to say this, so it's like the reverse of this. So this one, the top theorem says if c is a factor, then we know, if c is a 0, we know that x minus c is a factor. Okay? And this one says if we know that all the zeros, then we know that the polynomial can be written as a product of all those factors. So it's just taking the previous statement just a little bit further. And in case it isn't clear yet, what does the zeros mean? What's another word for the zeros? What does that mean? Devin? Yeah, these are the x-intercepts. Sometimes people call those zeros. So for example, if we know the zeros of this polynomial, let's say we know the zeros are 2, 5, and minus 6, then we can write the polynomial as the product of x minus these three things. Right? So since 2, 5, and negative 6 are zeros of p of x, we know that it can be written as factored form as x minus each of them. So x minus 2 times x minus 5 times x minus minus 6. Right? And so the x minus minus 6 is going to be a plus 6. And this can be useful because now we know what the polynomial is. We can just distribute this all out, right? do a whole bunch of distribution, and figure out what the polynomial actually is. And so I'm just going to write down those steps just to be clear about it, right? So the first thing I'm going to do is make the minus 6 a plus 6. And then I'm just going to start combining these things. I'm going to start distributing. So I'm going to distribute the minus 2 and the minus 5 first. So when I FOIL those out, you get x squared minus 5x minus 2x plus 10 times x plus 6. And then we could keep going. Do I want to FOIL this next one out? Do I want to distribute it like this, or should I do something else first? Yeah, it's a really good idea to combine these like terms. Like, there's nothing stopping you from FOILing this out, but if you do it like this, you're going to end up with 8 terms, right, because there's 4 in one times 2 in the other. But if I combine the minus 5 and the minus 2 first, then you only have 3 times 2, which is 6, right? So it makes it easier to do the minus 5 and the minus 2. So we'll have x squared minus 7x plus 10. And then we could just FOIL this now. I guess it's not FOILing technically, it's just distributing. We'll distribute this, and we get x cubed minus 7x squared plus 10x plus 6x squared minus 42x plus 60. And we see that we've got some like terms. We've got a couple of squareds, a 7x squared and a 6x squared, or a minus 7 plus 6, I mean. And then we've got a plus 10x minus 42. And so we can combine those like terms and get our final answer of x cubed minus x squared minus 32x plus 60. So if we know the zeros, using the factor theorem above, we can just kind of write out the polynomial in factored form. This is its factored form. And if we want it unfactored, we just distribute. Any questions about that? And so this is kind of the straightforward way where they're just like, they're just listing the zeros, right? They're just literally telling you 2, 5, and negative 6. The slightly more involved version of this would be when they give you a graph and then tell you, and then you have to look at the graph and figure out what the zeros are. So for example, I don't know what this polynomial looks like. I haven't graphed it, and I have a general idea what it looks like because I know how to graph polynomials. But the point is, I know that it crosses at minus 6, it crosses at 2, and it crosses at 5, right? It's going to go through those 3 points. And so if you're given a graph, you can just look at the graph and see the points, and then do the same thing. And that's what the next page is. And so this is like the slightly less complicated version, and the next page is the only slightly tiny bit more complicated version. So let's look at that page. And so it's the exact same question as the last one, right? Find the polynomial. This is the exact same question. Find the polynomial, except they're giving you a graph instead of telling you what the zeros are. So my first question is, well, let me just point out, right? This is a graph. It's telling us the graph. And it also says it's degree 4. What does degree 4 mean? So what about x to the 4th? Yeah, x to the 4th is the biggest power, right? So this means that the highest power in the polynomial has got to be x to the 4th. Right, that's what the degree means. And you can just look at the graph and see what the zeros are, right? I'm going to draw them on here. Here's one of them. Here's another one. And here's a third one. So these 3 zeros, we can just look right at the graph, and we see that the zeros are at x equals minus 2, minus 1, and positive 1. And now this is a problem just like the last page. Right? We just had to look at the graph and figure out what the zeros were instead of being told them. But now that we wrote them down, it's like the same problem. And so I know then our polynomial can be written as x minus those things, right? So x minus minus 2, so x plus 2. X minus negative 1 is going to be plus 1. And then x minus positive 1. What's the problem with this? I think I heard it, Andrew. What were you thinking?
The highest power you'll get is 3.
Yeah, if we multiply this out, the biggest power we're going to get is the 3. We'll have x times x times x is going to give us 3. So this is currently a degree 3 instead of 4, which is what we want, right? The problem's telling us it needs to be degree 4. So what's going on here? Does anyone know what I'm about to say? What's the issue? Or what's the correction that we need to make? Is there anything about this graph so something to do with the graph, and one of those roots is different than the other two? Yeah, the one at x equals 1, what about it? So you're absolutely right, but what is it about that one that made you say that?
Because at that point it's doing that like basic curve of the x squared graph.
Yeah, this x equals 1 comes down and just barely touches the graph, or the x-axis, and then goes back up, right? So like compare it to the other two. There's two troughs here. This is the bottom of a trough, like a low point, and this is another bottom. And if we go up from this one, it hits two separate zeros, and this one just hits 1. And so we say that roots that are like this, roots that like are x equals 1, we call a repeated root. So when a function just touches the x-axis like this, like here at x equals 1, it is a repeated root, i.e. it occurs more than once. And moreover, it has to occur an even number of times. For our purposes, we'll just assume it occurs twice. But it could be a fourth or 6th or 8th. But we'll just assume it has 2. And so I'm going to use a vocab word before I define it, but just write this down and then we'll define it. So i.e., we'll say that it has multiplicity 2. I'll define that down at the bottom in a second. But multiplicity kind of means what it sounds like. It means that the number of times that root appears is twice. And so we had a pretty good start to our polynomial, but it's not quite right. What we need to do is we need to write the x minus 1 root twice. See, so meaning multiplicity 2 means that it happens twice. And so I write it down twice. And in other words, it gets a square with it. Right, so those x minus 1s can multiply together to give us an x minus 1 squared. And now, this is degree 4, right? Now if we multiplied this out, we would get x to the 4th plus blah, blah, blah. The biggest power would be x to the 4th now, because we've got an x times an x squared. And so that's going to give me 4, right? And so this is good because this is degree 4, and that's what we wanted. And if we really wanted to, I'm not going to do it, but if the problem asks you to do that, we could multiply this out to get the polynomial. So we could multiply this to get the polynomial in unfactored form. I'm going to do a couple others at the bottom, just so you know. We'll look at a few more. But are there questions about this so far? Let me just define the word multiplicity, since I used it in a sentence and I didn't define it. So let's just write that down. So the multiplicity of a root is the number of time it appears in factored form. It's the number of times that root appears in factored form. And so looking at this example right here, right, x minus 1 has multiplicity 2 because it appeared twice. And so x equals 1 has multiplicity 2. And then x equals negative 2 and negative 1 both have multiplicity 1. So I'll just write that down. So for example, above, x equals minus 2 and minus 1 have multiplicity 1. And x equals 1 has multiplicity 2. You guys ever see that movie Multiplicity? This makes me think of this every time I teach this or whatever. I think it's called Multiplicity. Has anyone seen it? It's kind of an old movie. Yeah, with Michael Keaton. It's kind of, I was a kid when I watched it, but I remember laughing a lot at it. Anyway. He this guy makes copies of himself. And so he has 3 of them, and they're all doing different things, and blah, blah, blah. And one of them, he makes a copy of himself, and so the one is mentally disabled. Yeah, one of them's evil. One of them's just doesn't have mental capacity to do anything, so he's just really goofy. I don't know. It's a funny movie if you want to check that out. Anyway, it always makes me think about that when I write multiplicity. Did I see a hand over there? Question about this? Maybe someone was just really excited about Michael Keaton. I don't know. Let me write down a couple other examples just to be clear about this. So I'm just going to draw a few pictures at the bottom unless there's a question. Yeah.
So, if it's not specified, how can you know? If you have just an x squared.
How do we know whether it's 2 or 4 or 6? Is that what you mean?
Yeah, assuming that you don't have the formula there that says
Yeah.
it's supposed to be 4 or 6.
So to know that this is a 2 here, the question is, how do we know that's a 2 and not a 4 or a 6 or something? Because it's just repeated, and it just needs to be even. And so for one thing, this problem specified degree 4, and so that's how we knew that it needed to be a 2. The ones you'll see in the homework, usually it gives you a picture, and then it says which of the following could be the equation for this. And so only one of them would have an even number there. But if you don't have either one of those two things, you don't know. You're right. And so on a test or something, if I don't specify degree 4, I'm just looking for an even power there and odd ones in the other ones. Yeah. Because you're right, there's other ones that look just like that, but there's a 4 here. If we put a 4 right there, it would be that same graph. It really would. It would be a little steeper on the edges and things like that, but it would look very, very similar for the most part. Other questions, comments? So let me just draw a couple more here. So I'm going to draw one here, and then I will draw one, I guess, right here. Let's do, well, I won't give it away. Let's just draw this one. Let's say that one crosses at -3 and 0. And let's do this one where we assume it looks like this. So very similar, the same kind of looking graph, except the repeatedness is a little bit different in each one. Right, the multiplicities are switched in terms of which of those humps has a multiplicity of more than 1. So in the first one, right, the repeated, well, why don't you take a second? Take a second to write these two down, right? So in each one, there's a repeated root and a non-repeated root. Let's assume that it's just a 2. So let's have a square on it. And which is just to be clear, which is the repeated root in the left-hand side? 0. This is the repeated root there. And in the right-hand side, at -2. Yep. Again, let's assume those guys have multiplicity 2. That's a good question. No, so multiplicity, these ones that go straight through it could have multiplicity like 3. It just needs to be odd. But in general, we'll just assume that odd multiplicities are 1 and even multiplicities are 2. But it could technically be any even number. But again, in the homework, what you'll see is a graph with some options, and only one of the options is going to be an odd and even in the right spot. I think you'll see what I mean when you look at these. All right, so what about this first one? So we've got a root at -3, and it's a single root. We'll assume it's a single one. And so we get x minus -3 to the 1. And that's going to be multiplied times x minus 0. And it's a repeated root, and so we put a squared on it. And so in other words, our answer here is x plus 3 times x squared. And that's a real easy one. We could just multiply that out real quick, right? This is x cubed plus 3x squared. And that fits this graph because this is degree 3. Right? We've got a degree 3 with a positive coefficient. And so the ends are pointing in the right ways, and so that makes me feel good that this is right. So this is degree 3. We see that 0 has multiplicity 2, and x equals -3 has multiplicity 1. And then on the other one, so -2 is the repeated one here, and so we'll get x minus -2, which is a plus, right? And then x minus 4 to the 1. And so I'm not going to multiply this one out, but we also get x cubed plus blah, blah, blah. And so it's a degree 3. And we see that -2 is the one with the higher multiplicity. And x equals 4 is just 1.